Hey everyone, my name is Dave and welcome to the NTD Racing Speed Shop. This right behind us is, I think we're gonna call it Sharky. It is a 1996 Cutlass Sierra that we are preparing for the 24 Hours of Lemons. Well, what is that? That is a 24-hour endurance race where you have to show up with a car that you can justify that you paid less than $500 for the car, and then also all of the performance modifications that you do to the car. So we'll start with this one right here. I think you'd have to pay somebody about $100 to take it, so we have about $600 of performance mods that we can put on it. I think we're already about $10 to $15 into some really high performance suspension mods that are on the springs in this thing. But with that being said, the safety part of this is totally serious. We're going to be putting in roll cage safety seats, fire suppression, seat belts, and all those kinds of things. And there's no limit to the cost for your safety type stuff. And I'm a roll cage guy, so what I'm going to be showing you today, in case maybe you want to do 24 Hours of Lemons also, is how we're going to, in general, put a roll cage into a car like this. I've done a lot of roll cages. This will be the first time we're actually put a roll cage into a complete car, because usually I have a roll cage and I slap body panels on the outside. So I'm going to show you how I do the dimensioning. I'm going to show you how we put that into a program called BendTech. And then I will show you how I cut those tubes out and we weld this thing together. We'll use the Dragon A250, but you could also do this with 2 angle grinders and get there. The roll cage is going to cost us about $200 in steel. So let's go ahead and get to the build. We'll start with a quick walk around and then we'll get to some dimensioning. All right, I generally don't like to brag about my rides because this one is pretty sweet, especially all the rest that we got kind of going on down over here. So we'll probably fix that with a little bit of paint. I don't know. I want to paint this thing black. I think black with the Knight Rider light across the top would be awesome in a sweet like cardboard wing on the back. We'd be totally bitching. But here's what we got. This is a Cutlass Sierra. We spent already a couple of days, or a couple days ago, we took this thing and we gutted it because what the rules say, and we'll get to the rules here in a second that kind of dictate what we're going to do as far as a roll cage for this thing. The rules say if it's less than 3,000 pounds, then we can use 1.5 inch tube in this. And so we are literally just under 3,000 pounds. So I think we're gonna go with 1.5 inch, and if we're slightly over, we'll just start taking stuff out. I think we got a couple more pounds left where we could take out some speakers and those kinds of things. But you see, we got everything out of the car. I have an Energy race seat mounted into here. And some of the other things that we still need to mount in, we got some of the 5-point PRP belts, which we'll be using. I get these on Amazon. I'll put a link in these in the description below. We also have to put a in-car fire suppression where the actual fire suppression is pointed at the driver, which I kind of like. We haven't used that before in all of our other race cars. You know, I might kind of go to something like that, especially for my little boy's car or something like that. You know, just in case you're stuck in the car, you can pull it and put fire suppression on yourself and on the engine or wherever the fire is kind of coming from without having to move around. You just got to be able to pull the handle. So that's kind of cool. Let's kind of take a look and here I'll kind of give you an idea of what the game plan is for a roll cage, at least the mounting points. Now, where do I get the specifics for what the roll cage has to look like? Well, every race organization has some sort of document that goes through and tells you exactly what they expect as a minimum from your roll cage, whether it's SCORE, Best in the Desert, Ultimate Off-Road Racing. In this case, it is the guys over at the 24 Hours of Lemons, and they have some very specific rules, and they're different from all the other ones, so you got to get smart on what those rules are. So, you know, looking at those on the computer, and then over here looking inside the car, we're going to have it's kind of neat is having usually I don't like 4-door cars, but it's going to make this a little bit easier to put this in here, because what you'll see is I got this little lip right here. I'm just trying to find places where I can make the tubes land inside the car, but then also they'll be easy to weld and they will be strong. So I figure at these seams over here, if I tie all these in with some spreader plates on both sides there, we'll come all the way back here to the back trunk area above where the fuel tank is. We'll tie in some of the down tubes over here, and then up towards the front of the car, we're going to go ahead and tie in the A-pillar tube. So the A-pillar will kind of come down here. It'll come straight down right in front of the dashboard, and it's going to go ahead and tie into this piece right here. So the first thing we're going to do is we got to start with some spreader plates. In accordance with the rules, they have to be at least 24 square inches, so like a 4x6 or something like that. We might go slightly bigger than that. I'm probably gonna go 6 inches wide. I might go by 6, which makes it 36 square inches. And then what I'm gonna do is I'm gonna contour it such that it comes down here, it makes a bend, and another bend. It'll be able to weld all the way around that, but I'm gonna try to have the tube land on this one flat part right here, which should make it a pretty easy weld. And what I'll really be looking for is making sure I'm spaced out enough from the side over here so I can bring my TIG welder in from both sides and weld the back and get a full weld all the way around. Some of the other tricks we'll have to kind of work our way through is how we're going to weld the tops of the tubes to make sure that we get full 360-degree welds in there. So some tricks I've seen people use before is actually will cut holes below the spreader plate, run their tube all the way through the floor, weld the top, and then come back up, pull it back up, slide the spreader plate in there, weld the spreader plate, and then weld the tubes to the spreader plate. So whatever it takes to make sure you get full 360-degree welds is critical while we're making this thing. So the first thing we're gonna do is we're gonna hop on Fusion 360. We're gonna cut out these plates. We're gonna bend them with my press brake over there. And then we'll start getting those plates that will be our spreader plates in position, and that will allow us then to take dimensions off of those plates to make our pick point. Let's go ahead, hop on the computer, knock out some Fusion 360, and then on the Langmuir Systems Crossfire XR to cut out some steel plate. All right, so this is a quick look at the Lemons tech guide, and they call it How Not to Fail in Tech Inspection, but this is the roll cage that we're going to build, something like this. We'll get more into that a little bit later. Some of the differences, we don't usually build cross tubes like these in our desert race trucks. They're a little bit different. We kind of have a little bit more B-pillar support than what they have in here, but we're gonna build something that looks kind of like that. And then what we're building right now are what is called these spreader plates, and it says it's gotta be 24 square inches. Let's zip over to Fusion 360 and we're going to design these spreader plates. Now, why Fusion 360 and the Crossfire Pro? Because it's going to take us just so much less time. You're like, you could probably do this with an angle grinder. Like, you absolutely could do this with an angle grinder, but it would take a lot longer. You'd go through a couple discs, and I've cut thousands of pieces on my Langmuir Systems Crossfire XR. So this just really takes a lot less time. And so what we're going to do is we want to sketch. So we're going to hit this little sketch function. All we're going to do in Fusion 360 is easy. We're going to draw usually squares, lines, and circles. And then we're going to make 3D parts out of those usually. This is going to be about as easy as it gets. Now today, since we're cutting on a plasma kit table, you got the Y and the X axis over here. That is what almost all plasma cutters cut on that axis. And then the Z axis is usually what they call torch height control. So I'm going to select that plane to do this sketch on. I'm going to hit the G key on my computer, which I've set up in here to say, I want to make it a center rectangle. So I click on the center there and I can start scrolling out, and there's my rectangle. I set that up. You could also go under the little create button up here and scroll down, and it'll give you the opportunity to make a rectangle also. But this first one is going to be 5 inches across the base, and then it's going to be 6 inches tall. And that is one of the spreader plates. That's going to give us 30 square inches, which is more than 24 square inches. But that's going to help us kind of make those bends that we want to go around those contours and weld everything together, hopefully giving us the strongest structure we can get in there. Now, what I don't want to do is go in here later on and have to grind all the corners to make them look nice and round. So I'm going to go ahead and just put these fillets in here. I'll just remember that's a 0.4 inch fillet. I'm going to put in, because I'll put the same ones on the other ones. They all look the same. There we go. I'm hit enter on that, and there's my piece. Now it's 2 dimensions right now, but what makes things a little bit easier to cut on the plasma table is if you turn it into 3 dimensions. You see I have over here a sketch. I'm going to hit the hotkey E or the E key on my computer, and that's going to bring up this extrude option. I could also just go and find extrude somewhere up there. I've hit the hotkey so many times I can't remember where that button is. Now it's telling me I can make this thing in 3 dimensions. I can make it like any dimensions I want, but since I'm cutting in 1/8 inch steel,
.125 is what I'm cutting. And you'll see is over here, it says, when I hit the OK button, it tells me I'm going to create a new body. And when you do more complex things, this is something that's really important to look out for. So when I hit OK, watch over here, it says sketches, but I hit OK, boop. And then now it says, now I have a body. And that's a 3-dimensional part. And that's just one of the things that we're making, but I need to also make the smaller plates. I'm gonna make some 4x6s. So I'm gonna just say sketch again. I'm gonna sketch on that same plane. I might actually be sketching on the plane of that's actually this piece of metal, which might be 1/8 of an inch high. That just doesn't really matter that much for what we're doing. I'm gonna hit the G key. I'm gonna just make it somewhere in the middle. And this is gonna be a 4x6 inch. So I hit the tab key to go over to the 6-inch. I'm gonna do those same fillets there. I'm gonna say, make this fillet 0.4, and then I'm gonna put the fillet on all of the 4 corners. And there we go. I'm gonna hit enter. I'm gonna hit the enter. All right, there we go. Hit the hotkey E for extrude again. I'm gonna extrude that face, 0.125. Boom, there's my 2 pieces that I want to cut. Now, I need 4 of these over here, and I need 2 of these. So I'm gonna hit the M key on my computer to bring up the move function. I'm gonna click on the bodies. I'm gonna say, I'm gonna create a copy of this one. I'm gonna move that top one over, and then that's gonna allow me to create a copy. And in general, I want about, a quarter of an inch in between the 2 pieces, whatever pieces I'm cutting. And that way, as the plasma cutter goes down one side and the other side, they don't interfere with each other. So I'm gonna hit OK, and that's good for that. I'm gonna cut the 5-inch. I'm gonna hit the hotkey there. I'll just move this one. Actually, I'm gonna escape out of this. If I grab I'm gonna hit hotkey M again and grab this. If I grab this square, it's gonna let me move it in 2 dimensions. If I just grab the arrow, it'll let me move it, and I won't accidentally move it vertically, which will allow me to save a little bit of material. I'm just gonna move this thing all the way over here to this side, put about a 1/4 inch from there, hit enter, hotkey M, grab this piece, make a copy, move it over, say okay, hotkey M again. I'm gonna grab this piece and this piece, and I'm gonna make a copy of those 2. And I'll move both of them over, and then now I've got 4 nested that I can cut. Now, we've done that. We got all 6 of our pieces ready to go. Now we're ready to go and cut these things. And this is the beauty of Fusion 360. Still a free program for anybody who's doing this stuff at their home, is that you're right now in computer aided design, CAD, and you click on this button over here and you go to manufacturing. Now you're in CAM. And this is something unique about Fusion 360, is that it has computer aided design and computer aided manufacturing all in the same program. And it works really well with the Langmuir Systems Crossfire XR, and it's free, which is pretty awesome. So I'm going to go ahead and say setup. I'm going to cut over here, start my cuts from the top left. I kind of cut all my metal from the top left to the bottom right, and that's how I work through that. And I'm going to say these are the spreader plates, is how I'll name those. It's going to tell me I didn't pick all the pieces, but that's okay, because I'm going to do that when I go through the cutting. Now I'm going to go into cutting and tell it which tool I want to use. I go into my library, and I'm going to pick the Razor Weld 45. I've been using it for 4 years. I don't need to justify it anymore. It's an awesome plasma cutter. I got all the plasma cutters. I got like 5 Best Arcs. I've got a Hypertherm sitting right behind me on my Dragon A250, and then on my Langmuir Systems, I use the Razor Weld, and it's been a great one. So not as nice as the Hypertherm, but it does the job on the plasma cutter. Let me see. I'm going to cut at 100 inches, and I'm going to do my entries at 80 inches per minute. I'm going to go over this. I'm going to select all of the parts that I'm going to cut, and then I'm going to tell it I want it to start all these cuts right here. And the reason I want that to happen is I want it to cut in the direction it's going to cut is going to be clockwise around this thing. So hopefully what it'll do is it'll start here and cut this one, and then it'll cut this one. I hope it'll do that, because what I wanted to do is I wanted to cut and have all the thin material over here. By the time it gets over here, it's still connected to a bunch of thick material, and it won't move around too much. So we'll see which way it decides to cut. It doesn't always cut in that order. There we go. Now we're ready to go from our tool pass. We're going to make some G code, and I'm going to put this in the right folder. All right, I'll check a few things. The pierce delay 0.2, the cut height 0.063, all that looks good. I'm going to post it. And then now it's posted, I'm ready to take this over to fire control and the Langmuir Systems Crossfire XR. All right, this is the Langmuir Systems Crossfire XR. I've been using it for 4 years. I've made, this is my 5th race car I've made with this plasma table. Amazing machine. If you're interested in one of these for your shop, check out the links in the description below. It'll take you to Langmuir Systems and it'll get you $100 off. It'll also give us a little bit of bucks too, and we appreciate that because it helps us pay for all of our race cars. Also, code NTD Racing will save you $100 at checkout for one of the Crossfire tables.
All right, let's take a look at where I got started here. So the first thing I wanted to do was to level the car. When I say level, basically in between that point and that point, I wanted those to be absolutely level. And then I also made the car level left and right. I used these scissor jacks, only took 2 of them on both sides to first level the car. And that's gonna make it such that I can take dimensions using a plumb bob, since the plumb bob's gotta fall down straight. And it'll be, hopefully be pretty accurate. Anyway, besides that, a couple other things I need to prepare to take dimensions. And all cars are different. You kind of got to figure out how you're going to get dimensions. When I say dimensions, you basically need to be able to figure out for each point that you're going to find, what is the X, Y, and Z, or in Bentech speak, left, right, forward, aft, and up and down, or I think roof and ceiling and floor is what they use. So we're going to go ahead and check those out. And then also while we're in here, here are those landing plates. You can kind of see how I put some bends in those, and they're going to weld on there, I think pretty easily once we clean all that metal up inside there. The whole car, it's pretty bad. So that's how we're getting prepared to take all these dimensions here. I have my sheet of paper. There's basically 3 different things I need to do, and it was almost like 3 different disciplines of measurement, I guess, or at least 2. First is we need to find the base. This is like looking the top down at the car. These are where the A pillars are going to land. This is where the B pillars are going to land, and this is where those I don't know what they call them, kickers, the ones off the back are going to land. And I need to find the X, Y, and Z coordinates for all those. Now, I'm assuming, and it looks like the car is pretty symmetrical, so I basically only need to know half of those, and then I can mirror them on the other side. So I need to find 3 dimensions right there. To create the A pillar, we're going to start with this front one over here, and then what we need to do is we need to find 2 more points, the bend right around your knee, and then the bend that kind of sends the A pillar over your head back towards the B pillar. And then the B pillar, really only 2 dimensions is what we're going to find. Is the bottom one, this is the base of the B, that's this point right here. And then the top one, we're only going to have 2 bends to make the B pillar. We're not going to have it like kind of kick out or anything like that. It's, if you kind of look at the car, there's really no reason to have it go here and then go there. We're just going to have 1 straight tube kind of coming straight up over there. And then what we need to do is we need to find out how high do we need to make that cross tube. So this could really, it says X, Y, and Z. We really just need to know a distance to make the cross tube such that it will allow us to mount the shoulder belts, the seat belts to the back. And in general, you're kind of looking for about 6 inches off the back of the seat. About 0 to 4 inches below is kind of what we're looking for as to where those shoulder belts are going to go through the back of the seat. So to start with, a couple tools we're going to use. I mentioned a plumb bob. I got my grandpa's old plumb bob here, which I've been using on all of my race cars. I wonder what he did with that thing. That's pretty cool. And then also I just fabricated this up. I cut these little pointy pieces off of the plasma table. I just fastened them with some 1/4-20 bolts to this piece of angle aluminum, which I use for all my jobs I got over here. I get this from Home Depot. About 15 bucks for one of these pieces of aluminum. And then what I'll be able to do is I'll be able to lay this down between 2 points, and I'll be able to take that off and then take it over to my bench over there where I have a tape measure and get really accurate measurements for the distances between points on the base. Let's go ahead and we'll get started taking dimensions for the base. So to get the first 6 dimensions, really these 2 are in plane. So the Y and the Z are going to be 0 for this one. That one's going to be mirrored. The Y is going to be like 24 inches back for this one, but the Z will be 0. And then in the very rear, the Z and the Y and the X will be slightly different, but that'll be easy to find out. We'll go ahead and pull the dimensions off of that just using some levels. But to use this tool right here, I'm basically going to set the point of this right in that. I'm not sure you can see over there. There's a little cross I made on there. That's where the center of the tube is going to fall. And then I just kind of keep working until I get both these tips right on those X's. There, now that I have that, I'll just gently take this over to the workbench and measure the distance between these 2 needles. From here, to pull the dimensions off of this, I laid my tape measure out. I'm gonna start over here at the 10 and put that 1 point there, bring this one over here, set it down, and I see that I have about 59 and 5/8 of an inch. So I'll write that number down. I'm gonna go take the dimension at least 2 more times to make sure I get the same number, because these are pretty critical to make sure you get these dimensions right. So what do I do to measure the other vertical points that make up the A pillar or maybe the B pillar? I'll show you what I use. I use a plumb bob, and I kind of find the spot where I want that A pillar to come up and make the turn and go back to the B pillar. And it's right about here. What I'll generally do is go up and say, okay, I'm gonna mark that with a pen or a Sharpie on the roof on where I want that to go. I'm gonna run this plumb bob from there, and I'm gonna drop it all the way down and let it settle out exactly where it falls onto the floor or whatever it is, some kind of a reference that you can use. And I see where it falls there. I'm gonna go ahead and I make a mark right there also. And then all I'm gonna do is I'm gonna take the length of this, and I'm gonna use that, and I'm gonna measure that with my tape measure like I showed you before. And then that gives us the Z coordinates, and then the X and the Y are simply X comes out to the left or the right from the side of the car, and then back to that point, and now you have your coordinates for all of the points for your A and B pillars, and that's how I do that. All right, so before we get started on this whole thing, as far as using the CAD, we need to tell the computer what kind of tube size we're using and how it's going to interact with our JD squared or whatever kind of tube bender you have. So the first thing I'm going to do is go over to the tools and then down to tube library. I already have these other tubes in here, but I need to add in the welded seam with the 0.125 wall. All right, now that we have that in our library, we're gonna go back over to tools, and now we need to calibrate our die. And this will actually require us to cut off a piece of tubing, run it through our tube bender, and get some measurements. So we're gonna add a new one. We're gonna go ahead and call it 1. And then, now that we have in there, we'll run the wizard. And this will walk us all the way through all the processes to get the dimensions off of the tube after it is bent. And then all the calculations that it makes later on in the CAD will be accurate. All right, here we are, Bentech CAD. We've already done all the hard part. We took the dimensions. Now we just need to put them onto the screen. This is kind of the easy part a little bit. Let me talk you through just some of the pitfalls that I want to help you avoid that maybe I ran into before. I'm going to go over here and select those welded tubes. I got that because I put that in my tube library, and then I also put this tube right here, or this die in my die library. I can set that up. We'll use that here in a second. I'm going to start by just doing all of the pick points first. And here are some of the important things when you're doing pick points. Is first, you got to have somewhere to start. For mine, I'm starting from our passenger side bottom of the A pillar, and it's just going to be all zeros. That's that one there. Now the other side of the other A pillar on the driver's side is just over here to the left. So I'm going to put in, it's 49.625 inches over there to the left. Here's some important things. If I just hit the enter key, I'm going to kind of show you, there's that point right there. If I hit enter, nothing has happened. I actually have to hit the apply key to make it make a pick point. And then when I'm done doing that, you kind of want to make sure you really got to go over here and say, clear the values. Otherwise, you're going to have a stray value in there that's going to mess you up later on. So now I have the bottom of those two A pillars. Now what I'm going to do is I'm going to start making the bottoms of the B pillars. And I just referenced for the bottom of the B pillar, I referenced this point right here. I got it all zeroed out. It's the same elevation because I leveled the car based off of those points, but it's going to come back 32.25 inches. And then it's going to the right. It's going to be 0.3125 or 5/16 of an inch. It's going to the right. I'm going to hit apply. Now, I'm basically assuming that the car is mirrored. It's pretty darn close to it. So I want to make the same pick point, but on the other side. So I have to hit this as my reference point, and I want to swap this right value over to the left. I just click on left. It puts that value over there, and now I can hit apply. And that's why I can kind of go through it quickly, and we'll do the rest of those pick points. All right, so what I find is a lot of times is while I'm doing the pick points is you kind of get lost sometimes. Like, man, where am I here? If you go up here to projections and you say left side of the car, for example, then it kind of gets you back, and then you can say, okay, this is where the seat's going to be. This is B pillar, A pillar, and this is the back of the other roll cage. So that just kind of gets you back to something that you recognize, hopefully. Now what I'm going to do is I'm going to go ahead and put in the points for my A pillar. All right, got my A pillar parts in there. Again, I'm going to project it from the left side just to kind of make sure that it all makes sense to me there. Now let's go ahead and put in the last 2 points, which are our B pillar points. All right, that is all of the points, which will basically make up the basic parts of the roll cage. Now let's talk about how we're going to put the tubes in between those. Where do you start? Realize that you want to take care of all of the tubes that have a bend first. So in this case, I like to take care of the B pillar first because that's going to have some bends on it. The A pillar will terminate on the B pillar, so I'll do that one next. But that one's also going to have some bends in it. And then once I'm done with the tubes with bends, I'll connect them all with straight tubes. I'll show you why I'm going to do that here in a second. So let's start with the bent ones first. We're going to click on bend. We got the right tube. We got the right die up there. It's going to have 2 bends in it. I'm going to say okay, and it's going to go from this point to that point to that point, and then back over to this point. And I'll say okay. So there's that point. Now we want to let's go ahead and knock out these A pillars here. So I'm going to say we're going to have a bend. It's going to have 2 bends in it. I'm going to say okay. And the A pillar is going to go from this point to this point to that point. And then this is where you got to be careful because you see the way that the tubes are done here. Here is, let me get this in the center here. This is the pick point for this, where these 2 tubes kind of come up to for that B pillar. And you can kind of see the pick point is actually the extended center line of both of these tubes. Obviously one tube, but this is the extended center line of where those tubes would meet. Right there. So if you click it right there and then you go make a cut toolpath for the cut, it's not on the tube that you wanted to cut on. So you actually need to make sure that you select the tube. They also help you out here by making it color coded. So in this case, it's blue, telling you you are at the center of the tube. It can be purple, you're at the start of the bend, you're at the end of the bend, blue is the center. And later on, that will be yellow if you're terminating where another tube also terminates. So there is that one. We're going to go ahead and make another bent tube. It's going to be 2. Okay, and it's going to go there, and blue. And we'll say okay. And that is the A pillar. Now we got all the tubes on there, at least right now, that we're going to put bends on. Now we can start connecting the dots with some straight tubes. So we're going to click on this one up here, and you can kind of see, like I talked about, now that we're going to a place where there's already a junction of tubes, it's no longer turning blue there, it's turning yellow. And then it's going to go down to that one, yellow, down to there. This one right here should be a blue, and it should go over to a blue. All right, and then the last one here, you know, I got to do this cross tube here. I kind of want it to terminate before it hits that plate, so I'm going to make one more pick point down here to help me out with that. I'm going to say pick points. It's going to be along a line. I only want it to be about 1.5 inches up from the bottom there. I'm going to set this reference, and there is that pick point right there. I'm going to say apply. And so this tube right here, the straight tube will go from this point all the way down to that point. And then there's that. You can kind of click on the main, and you can see how this roll cage is kind of looking right now. So it looks good. Now let's work on this next part here, is this seatbelt bar that goes across behind this. We're going to put the shoulder belts. You can also kind of QC how you're doing. Like, let's say I project from the back. You can kind of look at it and go like, oh, you know what? It all looks symmetric, kind of like the way I want it to. You can project it maybe from the top and then check out the symmetry, or project it maybe from the left, and then you can kind of see. And so if you expected tubes to be superimposed on each other and they were offset, then you know you got an error somewhere in there, and you can fix it earlier the better. All right, cool. Let's work on this side tube. So we're going to go ahead and we're going to do pick points again along a line. And I know that I want the shoulder belt to be 27 inches high. So I'm going to go 27 inches. I'm going to set the reference as being this tube right here on the B pillar. I'm going to hit apply. I'm gonna set the reference on this other one over here, and I need to swap ends because it's got to be at the top, and I'm going to hit apply there. And now you can kind of see how those go. And then now I can put that tube in there that makes up that that seatbelt place there. Now here's one of the problems though, and there might be an easier way to fix this. I just don't know what it is that for me to cut these tubes, I don't think it'll do it because it thinks that this is one continuous tube. I don't know how it would do that cut. So we need to turn it into two separate tubes, and this is a way that I will do that is I'm going to say pick point again. I'm going to grab this line right here, and that's where it would be at 27 inches. I'm going to start manipulating this number here until I put that point right over top of that tube. And so I'm going to try 29 inches. That went the wrong way, so it must be more like 22 inches, and that's pretty darn close. And as I zoom way far in here, and if I go 21 inches, 0.8, that's getting pretty close. I'm going to backspace 0.7. That's really close. Let's say 0.75, and that's almost dead on it. You'd have to really zoom in close to see any separation there. So now that pick point continues a straight line across that tube. So now what I'm going to do, first I'm going to hit apply to make that a pick point. I'm going to hit delete, and I'm going to delete that whole tube, and then I'm going to create two tubes, which basically makes the same thing. But now when we go and cut those things, it'll cut them and create a tool path as two separate tubes. All right. So the last thing that we really need to make for this thing to be like a legal roll cage, we've got to do those sidebars that kind of go around the driver's, torso and his hips. And it's going to be, again, we're going to do along a line. I'm going to make that 21 inches high. I'm going to set the reference for right here. I'm going to say apply. And I'm going to do that all the way around to all of the tubes. All right, and then they have to be 7.5 inches apart from each other. So I'm going to make them 11 inches. That's like the minimum it's got to be. So I'm going to do the same thing all the way around for that. Again, 11 inches. And that'll put those tubes just a little bit more than 7.5 inches apart from each other. All right. These back tubes over here, I'm just going to connect straight tubes because no need to. That's going to be the side of the car that, it's going to be the passenger side. No one's going to be over there. But there is going to be somebody over here on the driver's side. So I kind of want that to kick out a little bit. So I'm going to go to single pick points again. I'm going to clear the values. And I'm going to kick that thing out to the left 3 inches. And I'm going to go forward 8 inches. And I'm going to start with this point right here. And I'm going to say apply. I'm going to go that point there, and I'm going to say apply, and then I'm going to do a bent tube in here. It's going to have one bend. It's going to go from there around through there, a point, and then I'm going to do another one, exact same thing. It's going to go from there and all the way through there. And then now we go back to main, and there is our 24 Hours of Lemons legal roll cage in accordance with the books. Cool. This is where we're going to leave this one off. So this is a completed roll cage. This is what we're going to cut out. The next episode, I'm going to show you how I plan out all the cutting and what kind of tricks I use to define where the cuts are going to go. And then we will cut this thing out on the Dragon A250. Realize that you could also do this manually. I'll show you all that stuff on the next episode. Okay, that is the tough part, is getting all of the dimensions. And just realize that every error that you can eliminate in the process, whether it is calibrating your tube bender, getting the dimensions down to like a 1/16 of an inch, every one will make those gaps in your welds just smaller and easier to deal with. And if you do it perfectly, you'll find that the BendTech software is so precise that generally you can't even get your fingernail into the gaps of the tubes as they cope together and the welds. And I'm gonna show you that in the next video. So next one, I'm gonna show you how I map out all the cuts and how they're gonna go, some of my philosophy in planning on how I'm gonna weld it together. And then we'll get the roll cage in there and see if we can't finish up this Sharky build. Anyway, a lot of cool stuff coming. I can't wait to see you next week. Hopefully we've earned your like and subscribe and all that stuff. But here's the important part, the way the YouTube algorithm works. If you don't select notifications, I promise at some point you won't see our videos ever again. So if you want to see more of this stuff, hit that notification bell to get notifications of future episodes. And I can't wait to see you next week. Take care of yourself.